Hi, I'm Dave East. I'm a boat manufacturer and boating editor, and over the last 4 years, I've conducted over 300 tests trying to help people choose their best boat. So naturally, when I saw the Evinrude PlaneTruth Challenge, it sparked my curiosity. How did they conduct these tests? Did they use the same propellers? Did they maximize the amount of horsepower available for each engine? Basically, were the tests fair? I contacted Evinrude, and I'm delighted to say they're going to let me conduct my own test. Let's start by taking a closer look at the boat. It's a center console. This size boat represents really the most popular size you're going to see in the saltwater boat market. I verified the measurements myself. The manufacturer says she's 25 feet 6 inches long, 8 foot 11 inches wide. It's got a dead rise of 21.5 degrees, and the dry hull weight is 4,300 pounds. The Coast Guard maximum rating on this transom is 400. So typically this boat's going to be powered with a pair of 200s. Evinrude chose the 150 HO to compare its torque against the larger 200 horsepower Yamaha. This is a common motor in saltwater. It's got a 25-inch shaft. It's an inline 4 with 2.8 liter displacement. This is the E-Tech G2 150 HO. It's also a 25-inch shaft motor, but it's a V6 with a slightly smaller 2.7 liter displacement.
Since this 150 is an HO model, it produces up to 10% more horsepower than the sticker.
The mounting holes vary from boat to boat, so we're going to look at the anti-ventilation plate. It needs to be mounted a ½ inch above the bottom of the hull, and that's precisely where both of these motors are mounted.
The gear ratio of the Yamaha is 1.86 to 1, and the gear ratio of the Evinrude is 2.17 to 1. The higher the gear ratio, the more torque the engine can deliver to the prop.
The most important part about dialing in performance is propeller choice. The attributes of a prop, diameter, and pitch. This is what's going to affect our RPM reading at the helm. If we choose a prop with too much pitch, we may gain a little speed, but the engine's going to be lugging and it's going to be working really hard. If we go with a prop with less pitch, yeah, the boat may plane a little faster, but we run the risk of over-revving. If you over-rev an engine, you're liable to have some damage to the power head that's not going to be covered under warranty. To get a baseline for the test, I did some research. Found out that the recommended prop for the Yamaha is a 19 Reliance. The recommended prop for the Evinrude is a 20-inch Rebel. This is where we're going to start. Now that we've looked at the entire setup, I'm excited about getting this boat out on the water. We're going to be looking at 3 parameters: RPM, time to plane, and speed. We're going to be using the manufacturer's supplied gauges for our RPM. We're going to be using a handheld GPS to test our speed, and time to plane, we're simply going to use a stopwatch.
On every run in this test, we started with the trim tabs trimmed all the way down. The test engine was adjusted for its optimum trim, and the engine we weren't testing was trimmed completely out of the water. Our estimated test weight was 6,200 pounds. To establish a baseline, we ran the boat with both engines. We used Yamaha gauges for the Yamaha and iCommand gauges for the Evinrude. Time to plane was 3.6 seconds. At wide open throttle, we recorded a top speed of 50.7 miles per hour at 5,650 RPM. For our first test, we ran each manufacturer's recommended prop. We started by tilting the Evinrude out of the water. We put the tabs down, then put the throttle down, and waited. Finally, after over a minute of trying to plane, we recorded an average top speed on our GPS of 9 miles per hour. We were turning 3,200 RPM on the Yamaha gauge with the throttle wide open. Part 2 of this test was to put the Evinrude G2 in the water and tilt out the Yamaha to see if the Evinrude could get the boat on plane. With the throttle down, our stopwatch recorded 12.1 seconds until we were on plane. After another 20 seconds or so, we recorded a wide open throttle top speed of 27 miles per hour on the GPS at 4,625 RPM. With the same props, the performance is not even close. But just to make sure this dramatic difference in performance is not due to prop selection, let's change them.
For our second test, we're going to use 2 props that have the exact same diameter and pitch. 15.25 inch diameter, 19-inch pitch. Yamaha prop, Evinrude prop. Typically we wouldn't do this. We've got 2 different engines, 2 different gear ratios, but it's going to give us another benchmark to add to the test.
We relaunched the boat and took it out on the water for our second test. With the 15.25 inch by 19-inch pitch Saltwater Series prop on the Yamaha, we tried once again to get the boat on plane. After running the boat for over a minute, we could not get her to plane. top speed we recorded at wide open throttle was 9 miles per hour at 3,200 RPM. Then we put the Evinrude in the water. We put the throttle down, and this time it took a bit longer to get the boat on plane, 12.2 seconds. The Evinrude, with the same propeller dimensions as the one on the Yamaha, at wide open throttle, had a top speed of 25.7 miles per hour at 4,700 RPM. Once again, there was a dramatic difference in the performance of these two engines. At this point, we went back to the dock to see what we could do to help the Yamaha.
We've run 2 tests so far, and the Yamaha just can't get this boat on plane. So what we're going to do, we're going to drop down to an 18-inch pitch Reliance. Should gain a little bit of RPMs and maybe get the Yamaha some more performance.
Once again, we took our 25-foot center console out for a test run. Now we had an 18-inch pitch prop on, about the lowest pitch we dared to put on without over-revving and harming the engine. The Yamaha picked up a few hundred RPM to 3,550, but still couldn't get our test boat on plane. Top speed with this prop was 10 miles per hour. So once again, we went back to the dock to see what we could do to make sure our testing was fair. Perhaps changing the position of the engines would make a difference. For the 4th time, we put the boat back in the water to see how our center console would perform.
Even though both engines are standard rotation, Evinrude agreed to swap them to either side of the transom to see if it changed our performance numbers.
We ran out to the test grounds on both engines, then tilted out the Evinrude. With the factory recommended 13 3/4 inch diameter by 19-inch pitch Reliance 3-blade on the Yamaha engine, the boat hit a top speed of 9 miles per hour at 3,000 RPM. Clearly, putting the Yamaha on the other side of the transom did not help the Yamaha 200. Then, we trimmed the Yamaha out of the water and ran the test with the Evinrude. It took the Evinrude an average of 12.2 seconds to plane with the E-Tech G2 150 HO. Once on plane, she topped out at 27.9 miles per hour at 4,675 RPM.
Okay, I get it. I see why Evinrude wanted to put their 150 HO up against a 200 horsepower 4-stroke, but I wanted to see what a 200 would do up against a 200. So we've swapped the engines out. We're going to go out and get some more performance numbers.
With 400 horsepower bolted to the transom, we ran a top speed of 55 miles per hour, which is about 5 miles per hour faster than the E-Tech G2 150 HO. With the Yamaha trimmed out of the water, we ran one more test. The E-Tech G2 200 with a 15-inch by 21-inch Rebel 3-blade stainless steel prop planed our test boat in 10.95 seconds and hit a top speed of 31.85 miles per hour at 5,000 RPM.
Well, this concludes my test. I tried to keep it as fair as possible. We changed props, we changed engine trim settings, we even swapped the engines from side to side. We did everything we could to make sure that each engine was operating at its peak performance. And you know what? The numbers, they speak for themselves. I appreciate you watching. I'm Dave East, and I know what? I had a lot of fun. I hope you enjoyed this video too.